Hello ladies and gentlemen, I'm very pleased that you're joining me for this video. Today I'm going to talk about how I made the XLR DC block and load. Now, I'm sorry, this is going to be a slideshow video. I would love to constantly film what I do and have actual video footage and make that more interactive, but where I am in my life with the work that I do and the environments that I'm in, I just can't do that. I'm sorry about this, but please stick with me and I'll try and make this as interesting as possible. It all started with this guy. So I was doing some research into the FET head and how it worked, and I came across this project which uses two PCB mount connectors and a 3D printed case to actually create a FET head. Now, in this first version, he used some kind of foil to achieve shielding. In my view, this is really not the right way to do it, but it is very good as a platform just to develop this. So I want to give a big thank you to ZipDocs for developing this project. Now, one thing I'll say, please, please, please do not use black solder mask. It is very, very difficult to see the parts and the traces, and that can be extremely annoying when you're trying to debug or just deal with something. So this project has been superseded by this one, and this is starting to look closer to what I did. This is based on the Amphenol AC3F3MW, which is this kind of shell inline adapter thingy. And what he's done is made a PCB which solders to these 3 pins, just like the FET head, and you can solder some wires on these 3 pads over here. I've opened up his design in GerbV, which is a free Gerber viewer. This just lets us see the files which you send to the manufacturer. You can see here that he's got these 3 big pads, and one's on the back, then 3 pads on the front. I believe he used 0603 resistors, and you can see he's done it very nicely in a proper PCB editor with the silkscreen. I started with his design, and you can see I actually made his design on the bottom. Then I used some unplated through holes with no solder mask as snap points, and just put 3 PCBs in one. This middle one is the loading 2 kilo ohm load that I made. So the connection comes in and goes through these 2 resistors to ground, and the same on the other side. I designed this for 0805 resistors, which is quite arbitrary. Now, the way I did this was in Keysight ADS layout, which is not the easiest PCB tool, but it's very good for just doing these manual arrangements. I just manually put some rectangles down. I didn't use a kind of component to achieve that. This one is the DC block, so the signal will come in. There's some through holes for capacitors, and the signal goes out. And the same on the other side. On either side of this connection, you can see we have resistors. I just put 1 mega ohm resistors there. That just controls the DC level, so it's not a floating voltage. And you can see the ground just goes straight through. I just moved the via.gbr layer to the top, so you can see how the vias are contributing. I used a large connection here, which can have some problems if you're struggling to heat it up with your soldering iron. You can see the ground just gets its connection from this backplane. And I did make a mistake here. I should have made a cutaway on the ground plane for these through-hole connections for the capacitors, but that's easily fixed with a small drill bit or a PCB trace removal tool. You can see on his version that he's used these quite small via holes instead of doing a large amount, and that will make it easier to solder for thermal reasons. And you can see he's properly made a cutout on this section to avoid shorting. I uploaded my Gerber files to JLC PCB, and you can see we have some preview here. The Gerber viewer isn't working today, but you can see what this is going to look like. I found the Amphenol inline shell adapter on Mauser and ordered 3 of them. Each one comes in an individual bag, which is kind of annoying. And what's also annoying is they decided to laser engrave their logo on the side, which I covered up with the label. I'm rather annoyed about this because they didn't say they were going to do that, and in the examples I saw, they didn't. So it's a bit of an unwelcome surprise. I don't like companies forcing themselves on you like this. Overall, I'm very happy with the quality. It doesn't come off on camera, but this is a very high quality item. So this is what I got back from JLC PCB. You can see they do the pre-tinned terminals very nicely, and these work pretty well. Honestly, I don't have any complaints. Sometimes if you ask for something a bit strange in like PCB shape or something unusual, they don't get it right, but honestly, it's pretty much your fault because you didn't tell them how to do it properly. So I've already broken these off. You can snap them or saw them, and normally it helps to take a file and just smooth out the broken edge. You can see I didn't do that on this one down here, but they will clean up pretty nicely. So the first thing to do with these is to unscrew this screw down here and pop out this connector. Then you see 3 wires which you can desolder. So it looks like this. You don't actually have to do both of them, just one of them is fine. So you can see I have the thing desoldered there, and that is where you're going to slot this PCB. Now there's really not a lot of room in the gap there. You can see that's really touching the sides just because it's slightly below center line, so that's just something to be aware of if you attempt this. You can see inside here there's really not going to be much room, so I tried to align the screw holes and you can see there's barely any room in there. It helps to desolder the grounding tab and just swing that out of the way. Initially I tried to put the capacitors in like this. This did not work, there was not enough room underneath. I'll show you what I did in a minute. I got some nice 100 microfarad 63 volt ones, but there is no way these would have fit inside the tube with the PCB. So if you are going to use big capacitors like this, you probably have to wire it up just loosely with the wires going directly to the connector. I had lots of problems with shorting, so what happened was I buzzed it out with the continuity mode of a multimeter outside the tube. Then I would put it in, screw it up, and it would then short. So what I had to do was take some of the packaging from the JLC PCB envelope and kind of cut it into a rectangle of 20 millimeters width approximately, and then I was able to slide it down the tube, and that solved those problems. I had an idea to improve this whole thing. So what if we put the PCB 90 degrees to the connector pins? That way we can make 3 holes, so these are just 3 plated through holes, and have the connections running that way, and then the SMD resistors won't really take up any room on the in the tube. These are just 0805s. So I started by downloading a connector model, so it has these 3 pins here. Now all you need to do is use the existing wires to make the connection to the other side. You could easily put one of these on both, and you would have room in the tube for quite chunky capacitors. In case any of you want to copy this, you can see I made this a 13.5 millimeter circle. These guys are 3 millimeter holes, and I had a 3.95 distance here, and these are just 4.05 from the center line. I did not look those values up, I just based them on the 3D model that I downloaded. Thank you all very much for watching. I really appreciate the views, likes, and comments. I will read every comment, of course. I am currently working on addressing Soldrip's comment from the last video, so stick around for that. I hope you all found this interesting, and goodbye.